Hi, everyone. My name is Paul Ganssle. I'm a software developer at Bloomberg. I am also a prolific contributor to open source and maintainer of a couple libraries. I've been lately maintaining setup tools, and for a long time I've been maintaining dateutil. So as a library maintainer, I spend a lot of time thinking about interfaces, how programmers are going to interface with my library, and what they see when they just look at the documentation or whatever. So, of course, if I were to give all my opinions and thoughts about this talk would be 3 hours instead of 20 minutes. But I'm just going to drill down into one specific thing, which is sort of namespacing and how do you deal with functionality which is fundamentally similar to other functionality you have in there, but has a slightly different interface. So this is these are a couple of general principles that are going to come up in the talk. The first one is that related functionality should be grouped together. So you can namespace your functions by module, like the square root function is not just a regular built-in. It could be, you wouldn't misinterpret it, but it's in the math module instead. There's also the get function in requests. Get is far too broad of a name for any sort of function, but if you look at it in the context of this is requests, it actually makes a lot more sense. You can also namespace your functions by class. So one example of this is methods. So if you look at a string object, it has a strip method, which is operating on the data in the string. There's also methods that are on classes, like datetime.fromTimestamp, which creates a datetime from a timestamp. Related to this is that interfaces should be discoverable. So one way you can discover your interfaces is by drilling down into these sort of namespaces through modules and classes. Ideally, everyone would go to the documentation for your library and they would read it thoroughly before they write their first line of code. I'm sure you all know how often that happens. Much more likely what they do is they start writing code in PyCharm and then they type a couple things and they press tab and then they see what functions are available. And then maybe they hit the question mark thing that pulls up the doc string. Or maybe what they do is they open up a REPL and then they type dir and then they type the module name and just look at what's available. And increasingly, what you're going to see is people who have static typing and MyPy enabled, and they're going to say, all right, these functions work as long as the things that I'm passing them have the right types. Which leads us to the next principle, which is you should think about function signatures. So, oh, this isn't looking that great. Well, that's OK. So here's a real-life example from dateutil. I don't want to pick on someone else's library. This is relative delta. This is the constructor. And you can see it has these two parameters, dt1 and dt2. And then it also has this years and months and year and month. So what's going on there? How would you use that? When do you use each of these parameters? It's not immediately obvious. The intended use is that these first two are one kind of constructor where you construct a relative datetime based on the difference between two datetimes. So you're supposed to pass both of these. And that's the only time you're supposed to use those two parameters. And the other way you're supposed to use this is you're supposed to populate either years, months, year, month. And I'm not going to get into what a mess it is to have something called years and then something called year that leads to unending amounts of confusion. You can also have a sort of weird function signature if you have something where the return type depends on some logic in the function itself. So here we have some fake function called sendRequest. It takes a rec, which is a request type, and then this Boolean return context. And it's either going to return you a response or a tuple containing the response and the context. So this is not super great. Type checkers don't love it. This one is fairly simple, but you can have more complicated logic where you aren't entirely sure what the return type is going to be. I personally would prefer that any function should always return a type, a single type, or a class of types that are all substitutable for each other. They all use the same interface. A last general principle is that you should provide explicit versions of magical interfaces. So dateutil is sort of famous for its parser that can just chew up anything. You pass it anything that's even close to a date, and it'll parse it. It'll work just fine, right? But sometimes you say, it's actually a bug if you're passing me something that's not an ISO 8601 date, right? So in that case, the parser is not going to help you. The parser doesn't tell you what the format was. So we have this escape hatch in terms of the ISO parse. ISO parse is fast, and also it's explicit. So if you pass it something that's not an ISO 8601D, that will fail. So those are the principles. Let's apply them to an example. So here's an example class. It's a coordinate on the planet Earth. So it takes latitude and longitude. And it's mainly there because it contains this data. And then, oh, you can have this nice representation as a string with north and east instead of negative and positive or whatever, right? So here's an example. I have this mapping of cities to their coordinates. But what if I want to go the other way, right? Maybe I printed this out to some JSON thing, and then I want to deserialize it. I don't really have any way to take the strings and turn them to coordinates here. So naively, you might say, all right, let's write a function that looks like this, where we have an init that takes that either will take a string, and if it's a string, I parse it, or it'll take two floats, and if it's two floats, then I use the regular constructor. But if you look at the function signature here, the API that I wanted is something that looks like this, right? Where I have one form of it and then another form of it. The first one takes exactly one string, and the second one takes exactly two floats. This is just like, a C++ programmer would love this because they can actually do function overloading. But the actual API that I got was something that looks a little messier. It looks like this, right? You have something, it's called coordinate or string. What is that? It's a union of a float and a string. And then the second one is a float, but it's optional. So naively, you might say, OK, well, I should be able to pass the first thing as a string. It'll parse it correctly, right? And then I'll just pass the longitude as a float. But obviously, that's not going to work because that's not how it was designed. Or you could say, well, all right, the first one, I'll make sure that that first one is a float. But if longitude is optional, it must have some sensible default, right? So I'll just pass it one number instead of two numbers. It's because your interface is not super discoverable. The solution to this is to use an alternate constructor. So what you would do is you use your regular constructor that just takes the two parameters, and then you create this class method. It's just a method that you decorate with class method. It takes as its first argument the class instead of the instance. And you do the parsing in here, and then you call the class constructor to create your class. So here, I have something that goes coordinate, two floats, coordinate dot from string, and then a string, and both of them will give me the same answer. And the API, it's a little different than what I wanted, but it looks a lot closer to what I wanted. And this is a much more discoverable interface. Another benefit you get from alternate constructors is that it uses the normal inheritance tree. So if you have this thing, this is a data class that represents a point. I'm not going to go into what data classes are. If you want to learn more about that, my colleague, Scott Irwin, is giving a talk tomorrow at 1:30. I've seen it. It's very good. So here, what I have is, this is some point. It represents a point in Cartesian space. But I may also want to represent it as polar coordinates. If you don't know what the difference is, it doesn't really matter. Let's just say that they both take two numbers, and they both represent the same thing, but in slightly different ways. So I'm going to implement this as from polar, which takes the constructor arguments, and it passes it to this polar to Cartesian. And then when it does this, when it changes it over to the new base, it passes that to the constructor arguments. So if you notice, from polar is a class method, polar to Cartesian is a static method. The static method is just, I sort of have namespaced it under point, and it doesn't take the CLS because it's really just a function that does this conversion internally, and it's useful to put it under point. So here now I can use two floats to make my point, or I can have point.from polar, and then use two floats, and I get the point, but they're interpreted a different way. You can, if I want to have a named point, which is this like just a version of point that is a name, so 0, 0 is the origin, right? If I just naively inherit from that, I get the from polar for free, right? The only difference is that name is not propagated because I didn't take that into account originally. So what you can do is you can override the from polar method, and you'll notice that I don't have to override the polar to Cartesian method. Here, what I'm doing is you can actually call super inside the from polar, inside class methods, and it'll call the class method, the equivalent class method on the superclass, but using the base class. So essentially, what this does is this guy is the same as our from polar. So this will return named point with no name. And then once I have that, I can assign a name to it and return that. And once I've done this, I now have a from polar that takes origin without having to repeat myself. It's great. You'll notice that even though the static method it doesn't take a reference to the class, because the class method that calls it has a reference to the class that it's on, not the class that it's defined on, you can subclass and then override that behavior in the static method itself. So here's a three-dimensional point where I don't have to override from polar. Instead, all I have to do is change polar to Cartesian to do the equivalent math, but in 3 dimensions. So here, that just kind of comes for free. So far, I've just been telling you about alternate constructors in classes. But these problems, they occur just as frequently in functions, right? So what if you've probably seen APIs that look kind of like this. This is a contrived example. It's print text, and what it does is, if you pass it a function object, or a file object, it reads it and prints what's inside. If you pass it a string, what it'll do is it will interpret that string as a path, open the file path as an object, and then call itself with the file object. So the reason why this kind of thing exists is that, for the most part, so the generic best implementation of this that is really extensible is the version that takes a file-like object and reads it, because then it doesn't have to be a file. It could be string IO, it could be anything. But probably 90% of people who use this kind of thing are just going to say, all right, I have some CSV file or whatever. I just want to print it out. Why do I have to do this with context manager or anything like that? So you have this instinct to say, all right, I'm going to make it sort of magical in that it'll try and pick the right thing to do. But you have this complicated function signature. This is another example from dateutil. The dateutil's parser takes a time string, but if you look at what the return type is, it can either return a datetime or a tuple of a datetime and then a tuple of an unknown number of strings. The reason for this is that the parser has a fuzzy mode, and in fuzzy mode, it will just ignore anything that's not a datetime and then throw that information away. But some people want that information. They want to check if it's some weird thing, right? So there's a parameter you can pass called fuzzy with tokens, and that will return both the datetime and then the tokens you had. So this is a textbook example of the problem that I identified earlier on in the slides. So what's my solution to this? This is a pattern that, this talk is pretty opinionated, and this is not some mainstream opinion. This is just basically a pattern that I think I can make a good case for, which is to say that the constructor function is just a function that constructs the class that it's called on. And an alternate constructor is just a variant form of the constructor function. Maybe we can do the same thing with other functions. So let's take our print text example, and we'll modify it so that if you call the base thing with text, it'll actually print it. And then we're going to add this alternate form of it, this variant form called from stream, that only takes a stream. And then we'll add another one that only takes a path. And if it finds this path, it'll interpret it that way. And you can accomplish this other ways. I use this pattern in dateutil. It's used in the standard library in a number of places. You can totally do this. I can give you patterns for how to make it in other cases. But I've written this library, so I'm going to pimp that. And this library is called variants, and it adds syntactic sugar to make using this very easy. So the way that'll work is you have your primary function, and you'll decorate it with this variants.primary decorator. And then that sort of registers it as the primary. And then you do print text.variant, and then you call that with a string that is the name of the variant that you want. So to define from stream, I do variant from stream. And then I define another version of the function. And you'll notice that from stream calls print text. So the variant can call the primary. And when I do this path version, what that does is it opens the file path, and then it takes the file object, and it passes it to the from stream version. So not only can the variants call the primary function, they can also call each other. So here's an example of that working. I pass it this string, it prints it, I read it from a stream, or I can read it from a path. So this is an example where I have explicit dispatch. So if you notice, I've defined this path and text, and they both take just a string. And you can imagine another variant of this, which is from URL, right? So these two things are strings. This main one is a string. They're all strings. You can't really just dispatch on the type like we were in some of the earlier versions. So getting explicit dispatch allows you to do that. There is a pattern to do this implicit dispatch with single dispatch, which is in the standard library. It's under func tools. So you can register your sort of primary function as a single dispatch function. And then you register a path object, which is sort of takes your stringly typed path and turns it into a dedicated path type. And luckily, there is a path type in the standard library. So now you say, all right, if anything is a path, then it actually goes to this version that takes from path. And now if you want to do the URL version, there's no URL in the standard library that I know of. But it's pretty easy to just have a data class that has one parameter URL, and then we'll take the, and then we'll register that. And so now the interface looks like this, right? You call the same function, and then it dispatches on type. It's actually pretty clean. But why not both? Again, we're looking at magical interfaces with explicit hatches. So variance is compatible with single dispatch. So you can make your thing both a single dispatch and a primary. You register your variant as the path, and then you have your, and then you also call it from path. And so what happens is if you call it with a string, you get the string. If you call it either with a path, if you call the main version with a path, or you call .from path with a string or path, it will do the right thing. It'll have it be a path. But this is the explicit dispatch part of it. You can also call from path with something that's a string but not a path. And instead of dispatching this to the primary thing, it will actually it will rightly throw an error because we were expecting a file path and we got a string. And if we want to go back to the parser example now, you can get variation in return type. So you have this parser.parse. It has fuzzy and fuzzy with tokens. We could rewrite this as fuzzy parse, and the primary function just does fuzzy parsing. It always returns a datetime. And then you have a fuzzy parse with tokens, and that will always return a datetime with tokens. So now you have another clean version of a sort of messy interface. Other things that I did not mention earlier is you can have variation in caching behavior. So this one is in dateutil, this sort of example. You have some config. It has an LRU cache. So you call it subsequent times. It won't hit the function anymore. This function actually calls the variant called nocache, which doesn't hit the cache. So what you get is if you call this once, it calls the nocache version. If you call it a second time, it hits the LRU cache. But if you call it with getconfig.nocache, it bypasses the cache, and it'll always call the main function. You can also get variation in async behavior. So with async IO coming out, you've had this explosion of libraries where they have basically two exact same versions, two exact same hierarchies of functions that are the same, except one of them is async def and one of them is blocking, right? You can use this variation thing. You say the async one is the primary, and the blocking one is a variant. So if you call myfunc, it gives you an async generator. Myfunc.sync, it gives you a synchronous decorator. So I think to wrap up, essentially, what I'm aiming for is syntactic marking of relatedness. You could use a naming convention with an underscore or something, but that doesn't give you a sort of clean top-level API. If you're using syntactic marking, you can do something like what I did for variants, which is write a Sphinx extension that detects when things are variants of each other and nests the variants under their primary. Also, for tab completion, here, if I'm using this underscore thing, I have prime factors underscore, print text underscore. I see all the variants and all the primaries just from the beginning of it. And if I have function variants, if I start it, I only see the top level stuff. And then once I've completed to my primary, I can see only just the variants. So this is a much cleaner way to discover your interfaces. So that's the end of the talk. But what would the end of the talk be if I didn't have a variant of it? You can find, here's some plugs. You can find it on PyPI and on GitHub. It's open source. And in 2 weeks, if you come to PyData NYC, you can see my talk, Contributing to Open Source, a guide. So you can learn how to contribute these new, with these new clean interface skills back to variants. And then a week after that, you can come to Bloomberg and go to the PyPA packaging sprints and work on Python packaging tools with the information you learned in contributing to open source. So I don't know if I have time for questions. Time for questions? No. I have 4 minutes for questions. All right. Who has questions? Yes.
You mentioned that you have meanings. I was wondering, I can suddenly like typeface dispatch, like native.
Yes, I would. Mainly because if you think about it, so if you think about the polar and Cartesian coordinates example, that's not really something that you could easily wrap in a class, right? Because you'd have to have separate polar and Cartesian classes. And in fact, alternate constructors are a fairly common pattern in C++, which is strict. So any other questions? Or did I answered that adequately? OK, good. All right, cool. Thanks.